Well, good afternoon, everybody, and welcome along to the final session of DBA Fundamentals for 2017. Once again, I'm your host for this session. My name's Warwick Grudd, and I'm hosting Kevin Klein from SentryOne, and he's going to talk to us about 10 surprising performance killers on Microsoft SQL Server. Now, before I hand over to Kevin, I do have some house rules or slides to take you through. The first one is, for those of you, a big thank you to our sponsors, SentryOne. Without our sponsors, it would make it difficult to have this session for you to be part of. If you haven't already been along to the SentryOne website, and they've just rebranded, or I shouldn't say rebranded, but had a facelift to the wonderful website, and it looks fantastic with what we're able to pull down from there. But we've got some fantastic articles, videos, downloads, ebooks, and demos that are there to assist you improve your knowledge and assist you along in your professional career. So make sure you go along to the SentryOne website and look at all of that is available for you. Now, just to let you know, this session is being recorded and will be available up on the DBA Fundamentals archive site, probably within a couple of days after today's session. So you'll be able to come back and review this session at any point in time. Those of you who are aware, there's many different virtual chapters, local chapters, SQL Saturday events. We've just had PASS Summit. So make sure that you stay involved with PASS, and you can not only learn from these sessions, but also network with other fantastic people and like-minded people in the industry. I'll hand over to Kevin right now, and just to let you know, throughout the session, feel free to ask any questions. I will be monitoring those, and Kevin will be looking at answering those towards the back end of the session. So without any further ado, I'll hand over to Kevin.
Thanks so much, Warwick. And thank you, everyone, for carving out some time today. I know that you have a lot of obligations, and so I'm grateful to you that you've decided to spend some of your hard-won time with me during this presentation today. The presentation will pack in a lot of information into a relatively short period of time, and so one of the first and most frequent questions I get is, will this be recorded? Which Warwick, thankfully, has already answered for us. Yes, it will be. And the second question is, how can I get the slides and the T-SQL scripts that you use for your demos and so forth? And so those are also available. You can always email me. I'm at kcline@centuryone.com. And I'll also put up a blog post for it as well, so you can also download them via a blog post if you would prefer. All right. So as Warwick said, I work for SentryOne. We make a large collection of products, I guess you could say, for the Microsoft data platform. We try to be the best of breed for SQL Server. So unlike other companies out there in the marketplace, we don't make database monitoring and alerting and performance tuning products for any other data platform. We don't make them for Oracle or say DB2 or anything like that. And we specialize in SQL Server, and we go both broader and deeper than any of the other vendors. So we show you not just SQL Server itself, but we can show you all of the virtualization activities that are happening on both your host and your guests, on analysis services, both tabular and multidimensional. We show you everything that's happening in the cloud. We show you everything that's happening in some of the high-end products from Microsoft, like SQL DW or APS, which is a very high-end system. If you want to take a look at any of these, we'd be happy to give you a live demo. That's at Book a Demo, centuryone.com/bookademo. But as Warwick said, that's not the only thing we are about in the community. We do a lot of other things as well. For example, we have popular website. SQLperformance.com is a very popular website. Lots of great quality content there. I don't have a specific bullet point for it. I have one at the very end, but I'm going to mention it right now in passing, and that is that we make a product called Plan Explorer. And if you have ever used Management Studio to do query tuning and to look at execution plans, SQL Server Plan Explorer, Century 1 Plan Explorer, I should say, takes all the guesswork out of that query tuning, and it's completely free. It's so free that we don't even ask for an email address or anything like that. You can just go to the website and download it and start using it. And I encourage you to do that because it is great. In fact, it was one of the things that first attracted me to work for this company back in the day. Another thing that's very popular about our different offerings is that we have a series of ebooks that are normally $10 each in the Amazon Kindle bookstore, but you can get them all for free. Each you don't have to pay for any of them. And you go to century1.com/ebooks and just fill out a little bit of information there. Give us a website, or I'm sorry, give us an email address so we can send you the ebook files, and off you go. They're not little throwaway pamphlets, you know, that are 30 pages long. I've seen a lot of ebooks like that. The shortest of these is over 300 pages long. So they're full of articles written by the best in the business, people like Paul Randall and Jonathan Cahias and Aaron Bertrand, just, you know, really, really well-known, highly lauded speakers and writers. So it's really, really worth your time to get your hands on those. So this is me. Actually, it's not a real recent picture. It's about 4 years old, and I have gone gray since then. So my beard is mostly gray these days. But if you are on Twitter, I would enjoy connecting with you. I'm at K.E. Klein on Twitter, Facebook, and LinkedIn. So you know, it'd be a great thrill to connect with you. My blog is mentioned here, and that's where you'll find the blog post that will have the slides and scripts for this particular session. And then, as I mentioned, my email address, kklein@century1.com. I've been blessed throughout my career to be working at places that were doing cutting-edge activity with database management systems. I learned the trade back when mainframes were still pretty prevalent back in the mid-'80s. And relational databases were new then when I worked for NASA, and I was part of the team that built the water recycling system, the air recycling system that's still in use today in the International Space Station. For many years, I was the manager for database systems and information architecture at one of the world's largest accounting firms. Actually, I think it's the largest one today. And at that time, we were the largest Microsoft customer, private customer, and so I was tapped, one of the original 9 people that got together and formed the Professional Association for SQL Server, which is the organization that this webinar is presented to you through. It's a virtual group of PAS. And so I was one of the founders and early presidents of that organization. Then I also write a lot of books. My best known out of 11 is SQL in a Nutshell. So, yeah, I've been busy. Now, let's talk about problems that we have in performance, right? This particular little graph here is quite simplistic, and it comes from a study that Gartner did back in 2008, in which they examined closely what were the issues that companies or organizations that were implementing relational database systems, where were those difficulties and problems coming from? And one of the surprising things that they encountered is that many people tend to say, when they encounter a performance problem, something along the lines of, well, we haven't put all the memory that we could possibly fit into this server, so why don't we throw some more memory at this and see if that fixes the problem. You know, or they'd say, oh, well, you know, maybe we need to reinstall something or reconfigure it. But what the research showed is that the actual hardware itself is seldom the core problem in performance on database systems. Only about 5% of the time is it actually the hardware that is the smoking gun, if you will. settings for the Windows OS or the Linux or Unix OS, settings for the SQL Server or whatever the database that might be running, Oracle database, for example. That's another 15% of the problems. 80% of the problems, though, are related to code, or perhaps the interplay between code and the database design, right? And so, you know, if you're writing code that is really sloppy, I always call it sucktacular SQL, right? If you write really sucky SQL, it's just going to suck up all the resources that database server has. It'll consume everything, right? All the memory, all the I/O that's available on it. And so, yeah, it's very easy to bring a database server to its knees because you've written, or you know, a dev team somewhere has written really bad code, or they've got a really bad database design, or even worse, both of them at one time, right? And so the studies bear that out. So I'm going to take you through a few real quick lessons, and then I'm going to take you through some deeper samples of code about how to find out if perhaps your database is experiencing some of these surprising problems that a lot of people don't realize are lurking inside of the system. And work, do please interrupt if I'm starting to break up or the latency is bad or any of those things. So,
Will do.
All right, thank you. So we'll look at the hardware side a little bit, but hopefully we'll be able to spend most of our time on the database side, talking about the design of the database and SQL code, right? So here's an actual customer that I had, a real-world major financial institution headquartered in London, branches all over the planet. One of their core banking applications was processing tens of thousands of transactions per second. And I'm not talking about the IOPS. You know, each of these transactions had many, many IOPS each. And also, all of the SQL servers were always in availability groups, right? So there were hundreds of nodes, and each of those had hundreds of secondaries. So it was a very complex system, a very mission-critical system. And this is what the main server looked like when it was under load. If you've ever opened up the task manager and taken a look at perhaps the CPU graph or one of those sorts of things, you can see that it was a very stout server, and it was also very heavily utilized, very heavy CPU all the time. And that's a little bit of a surprise, to be honest, because many of the SQL servers that I work with are seldom CPU bound. They're usually I/O bound. So let's start with a little talk about CPU. And one of the things that is quite an annoyance is that the Windows Server default settings are really stupid. They're really bad. And it's strange because the fix is extremely easy, and yet it has never been changed inside of Microsoft Windows Server. And what the problem is that the balanced power setting is the default setting for how how Windows Server will do its different workloads, right? So what that means is balanced power, is one of many choices. You could have power saver, and then you can also have high performance. And balanced and power saver make a lot of sense for a laptop, but they don't make any sense at all for a high performance server. And yet this is the default. And what that means, if you're running an Intel server, Intel CPU, you're actually only getting 78% or perhaps 71% of the total CPU capacity. You know, the gigahertz rating, if you will. It's stepped down. The clock speed is stepped down. And so it's the kind of thing that, wow, why would we ever want that to be the case? Well, I can't tell you how many other DBAs I've talked to over the years who said, hey, you know, Kevin, I don't have to worry about this because we bought our servers directly from HP. or from Dell, or from whatever the vendor that you might prefer. And as it turns out, I begged them to go and check, and they went and checked, and sure enough, the consultants from HP didn't know that either, and the consultants from Dell who set those up didn't know either. And so this is the kind of thing that I encourage you to go back to your office, or if you're at the office right now, take a look, and you might be surprised how many Windows servers that are running SQL Server, or even other kinds of important services like Exchange or SharePoint and what have you, they're all experiencing this problem. So you're missing out on free performance. Now, a couple other points about CPU as well is that licensing can be a big issue, and it can add enormously to cost. And one of the very interesting things here is that when you start to look at licensing, we're caught in this kind of between a rock and a hard place, if I can use that expression. And so in order to get these ever-increasing performance ratings that the different CPU vendors want to achieve, they've long kind of maxed out the maximum CPU speed that they can sustain. It is a crystalline structure, and so if you go much above 2.5 gigahertz, your crystal can melt. So they realize, well, we can't keep making the gigahertz clock speed faster, but what we can do is we can fit more cores onto the same silicon wafer, right, into the same socket. And so we have many different CPUs that you can purchase now that have more and more cores on it. And you have to license for all of those cores here. But the problem is many workloads don't get any benefit at all because they're single-threaded. In particular, this is most noticeable on the SQL Server analysis services side of the house, but there's also plenty of activities inside of SQL Server that are single-threaded. The further back you go in versions of SQL Server, the more likely it is to be single-threaded, and that means that you get no performance benefit from having lots of CPUs because it only runs on one CPU at a time. There is a blogger named Glenn Berry, and he writes for SQL Skills, and I encourage you to take a look at his content because now that I think of it, he's been publishing these posts lately on SQLperformance.com in which he assesses and analyzes all of the new pronouncements by Intel and AMD and so forth, and tells you what to expect with your kind of workload, what kind of benefits you might get out of the newest chip architecture. And so make sure you give that a little bit of time and read over that, and he'll tell you whether this particular CPU is better or worse for a single-threaded or a multi-threaded workload. So it's very insightful and very useful information. And again, that name was Glenn Berry. So that's CPU, and that's kind of surprising stuff for me. I didn't realize that balanced was the default, and that if I didn't change it, it was going to be a big problem. Now, another area that I was surprised about was on memory, and there's a few surprising things that crop up here. Of course, one caveat I'd like to throw out is that more memory is usually better, and usually is kind of a funny term because many people I talk to think of it as being always better, but that's not guaranteed. And there are reasons for that, typically because you're not memory bound in the first place. So if you add more memory, it doesn't help because you were never constrained by memory before you added it. Maybe it was some other sort of issue, such as a CPU or a network or an I/O issue, something like that. Another thing that is surprising, and you can demonstrate this and I'm sorry, I have a typo here. This should be min and max RAM. So I apologize that I've got written there mix and match. One of the surprising things here is that the default settings, again, can hurt you. SQL Server is designed to be very resilient, and so if you don't make any changes to the defaults, SQL Server is intended to stay up and running and give you some kind of performance. Maybe not the best possible performance, but some kind of performance. Where this is a surprising revelation for me back when I learned it quite a while ago is that if you do not specify the minimum and maximum numbers for RAM, and really that's kind of interesting too, because those are the only two numbers associated with SQL Server's memory that you can adjust. There's a few switches you can flip that say, well, maybe do this part of your activities inside of cache or that part, but there's not really a whole lot you can do there. You can just say min and max. And if you don't change these values, even if SQL Server is the only application running on that particular Windows server, you can lose performance. And the reason for that is because the default value for maximum memory is what the theoretical limit was for Windows, I think at the 2016 release, which was about 2 terabytes of RAM. Okay? So what SQL Server does, interestingly, in its memory management algorithm, is SQL Server takes a look at how much memory it's got and adjusts moment by moment as time goes on. You know, do I have enough memory? If I do, and I'm getting memory requests, do I need to age things out of the data cache or the plan cache? You know, somebody makes a new request to put some new tables in the memory. Do I have enough memory? If I don't, and there's memory on the server, then I can request it from other processes that are running on the SQL Server. I can request it from Windows, for example. And then I can continue to adjust memory inside of all the caches. So SQL Server is constantly looking at how much memory it's got, how much memory are within the different caches inside of its allocation of RAM. But if you tell it the max RAM is the theoretical limit of 2 terabytes, SQL Server's algorithm is written such that it says, you know, I don't really believe that you do have 2 terabytes of RAM. I think I'd better go check. And so it runs a real quick CRC check and calculates, you know, and adds up how much RAM actually exists in the Windows server. And that means because SQL Server is checking memory so frequently, like could be hundreds or thousands of times a second, depending on what's going on that server, because it's checking memory so quickly, and because it may be saying, oh, you know what, I don't actually believe you that you have that much, you're going to be suffering from giving up several percentage points of performance simply on your memory setting. So get in there and change that and set it to a reasonable number for your particular SQL server. If you don't know how to do that, definitely drop me a note, ask it in the Q&A, and I can give you a link. There are a couple different ways to calculate that. I have some other slides that go into great detail about how to set max memory for SQL Server, since you do need to leave headroom for the operating system and other applications. It's not as simple as saying how much does this server actually have. Oh, well, the server has 64 gig of RAM, let me give it 64. It's not something very, very simple like that. Now, a couple other things that can affect memory as well are your parallelism settings and another one called cost threshold for parallelism. And then finally, a setting that can be set at the database level called optimize for ad hoc workloads. And I'll tell you this, I have tuned thousands of SQL Server applications over the years, and this optimize for ad hoc workload, I actually turn this on all the time now. In my experience, what I've seen is that it often helps, and I've never seen it hurt performance. So what this does is this actually enables us to conserve quite a bit of space. Again, your mileage may vary depending on the workload of the server, but it typically allows you to save some space in the plan cache, and so it can speed up performance and give you a little bit more cache to play with under heavily utilized applications. All right. So some surprising stuff with memory there. Now, another thing, too, I do want to mention here is there's this old setting that's been around for a long time. It's in Windows itself. It's not in SQL Server. It's called lock pages in memory. And it's a bit controversial because some people say do it all the time. Every time you got a SQL Server, lock the pages in memory. Other people will say, no, no, you shouldn't do that, because when you lock pages in memory, SQL Server won't give any of its memory back to Windows. Again, in my case, I kind of believe the correct answer to every technology question is, it depends. And in my case, it depends whether you turn this on how well you know and control that server and its workload. So if you know it very well and you know exactly what its memory consumption parameters are, you know it's what its behavior is, and you know that it won't take too much memory from Windows, then yes, go ahead and turn it on. The flip side, though, is that many times we don't know, nor do we have enough time to really get to know that particular SQL Server well, and especially if there's any other applications running on that server. And that includes other Microsoft things like analysis services and reporting services and that sort of thing. If I don't know what those are doing, and it's not very, very well known and repeatable and predictable and stable, then I do not turn that on. So it depends. Sometimes it makes sense, but other times it does not make sense to turn that on. Now, another thing I do want to point out too is how much memory has changed over the years, okay? And this is one area in which having a newer version of SQL Server can make a very, very big difference in terms of how well it manages memory. And the big transition was between SQL Server 2008 R2 and everything before it, and then SQL Server 2012 and later. So if you're on an older version of SQL Server, 2008 R2 or even earlier, you've got a couple things you're going to have to contend with. One is that it wasn't as good at telling you how much memory it was actually consuming. So SQL Server had a lot of things that it would do, like the common language runtime, multi-page allocations, the direct Windows allocations, thread stacks, and stuff like that, that were part of SQL Server, but they weren't part of the max server memory setting. So let's say you had a 16 gigabyte server, and you told it that SQL Server can have 14 gigabytes of that 16, and you're going to leave 2 gigabytes for Windows. Well, as it turned out, you could pull open Task Manager, and you would see that SQL Server actually had 15 and a half, and Windows was being starved and didn't really have enough memory to do everything Windows needed to do. That's because of this behavior in which a number of things that SQL Server used were not calculated in that max server memory setting when you went into the configuration settings. That's changed now with 2012 and later. Now, when you give it that max number, it's firm. It doesn't let other things slide under the radar and get past it. The other big change between that earlier set of versions and the current versions is that you can have a really bad problem with what we call internal memory pressure. Now, external memory pressure is when something comes from outside of SQL Server and pulls memory away from it in order to keep that server running well. So let's say, for example, for some reason somebody kicks off a big 40 gigabyte file copy on your SQL Server using the GUI. That tries to allocate the whole file space in memory and tries to do it all online right now. And so Windows makes a big memory request. That's external memory pressure being put on SQL Server. And that's pretty understandable. We all have probably had some experience with that. The big difference here, though, is with internal memory pressure. So with earlier versions of SQL Server, there were some pretty rigid rules about how much RAM would go to the data cache versus the plan cache versus all the other caches in SQL Server's RAM allocation. And so the problem there was that what if you had a SQL Server that had, for some reason, a whole lot of execution plans? Well, you could run into internal memory pressure on your plan cache, because in the older versions, SQL Server would say, give 75% of the the total RAM allocation to the buffer pool, and only the leftovers to the planned cache and the other caches. And there's a whole bunch of small caches. There's a sort cache, there's log buffers, there's hash buckets, there's all kinds of other small caches out there. And so in the old versions, they wouldn't allow any flexibility between those. There was a hard mathematical formula. In the newer versions of SQL Server from 2012 onward, we have I tried to put a little wavy line there between the data and the planned cache, and they are much more capable of letting those values float a little bit, so that you can have some flexibility if suddenly the planned cache needs more and the data cache has some available space, then it can control those things effectively and not give you out of memory issues, or just make you wait a long time for your memory requests. By the way, if you download the slide deck, I've got a lot of notes in the slides, so there'll be references for each of these different points that I'm making. For example, this one comes from a blog post from 2012 on MSDN. So all the details you might need are in there. So we talked about memory and CPU. Another surprising area of performance problems is in your storage, okay? And that's probably no surprise to anybody that storage is an issue, but there are some things that we can do about it, and a lot of us don't know about it. And so in that sense, it can be somewhat surprising. So here in this little customer weight stats report, we can see that a very large number of the most important weight statistics that this particular customer was encountering were all related to how fast the I/O subsystem can go. And that, in my experience, is probably 75% of the people that I talk to. It's usually there at the I/O level. I don't have a whole slide to talk about SANs, but let me tell you that your SAN administrator might be saying that your SAN is going to cure all of your performance problems. It's the panacea. It's the cure-all. And in my experience, many times I have found that the SAN is simply the central location of all of my problems, not the cure-all to all of my problems. So one thing a lot of people don't realize is that it's important on your SQL Server database files, not your transaction log files, but your database files, to have multiple database files, usually 4, 8, or 16, depending on how heavy your workload is. And here's the reason for that. When we've got a database, now I have TempDB illustrated here, but it could be any user database as well that is heavily utilized. What happens is we have these structures inside of the data file of a database. Things like the page file, the page free space, allocation markers. Every 64 megabytes or so in a file, you've got these markers so that we can find space to put new records, or if we're updating a record, where can I find some free space for the overflow when we added a 300 byte value to a column or something like that. There are other markers in there called SGAMs and GAMs and IAMs. So these are all allocation maps. So an SGAM is a System Global Allocation Map. The IAM is the Index Allocation Map, and this is kind of like your map to all the highways, right? So I need to do a range scan on the employee primary key clustered index, and I need to start on page 11,000 and go to 11,014. Well, SQL Server would use these structures every so often, every 4 gigabytes on the allocation maps, so the index allocation map, for example, to find its way to those specific records you want. Now, when individual users connect and do these kinds of work, it might hold a very brief latch, which is an even shorter term reservation of a resource than a lock. Latches are only in memory, and they typically resolve very, very quickly. Now, that's great. Latches are wonderful, and they can go very fast. The problem is if we have lots of users right? So I'm not talking about a system in which we've got 12 or 14 users. I'm talking about, you know, hundreds of users, 200, 300, 400 users. And so those latch contentions can really cause performance problems. And so the thing to note here on this example is this is one database file. So if we have multiple database files, we actually have a multiple of these PFS and GAMs and IAMs and so forth to find our way through the database. And so latch contention can plummet and eventually go away, or actually just simply go away, because we've got multiple database files. Again, I don't have a whole lot of time. We've only got another 25 minutes or so before we wrap up. But the performance profile is usually very good if you have 2, 4, 8, or 16. After that, it really begins to level out, right? So you don't usually get a really big performance benefit by having a lot more, unless you're one of these crazy edge cases where they have just the the most throughput needs of of the very highest end. So that's one surprising thing. A lot of people don't realize why having multiple files is important. Another one that is very important to know about is how SQL Server does its write activity to different files. And so what happens is SQL Server uses something called a round-robin proportional fill algorithm. So what that means is it goes round and round in a very sequential format, back to the start, then to the next file, the next file, the next file, back to the start, as it gets write requests. And it does the writes proportional to how full each of the files are. So if we have one 4 GB database file, of course, very predictable results, because all the writes are going to go to that one file, and it's eventually going to fill up, but you can tell where all the workload is happening. Now, if instead of creating 4 files of the same size when you start, you later on add a new file. Let's say we create another 4 GB file because the first one was 80% free or full. We're not going to get predictable and stable results anymore, because SQL Server is actually going to go round robin, first on file 1 and then on file 2 and then back to file 1 and file 2 in that round robin format, but proportional to how full it is. So that means we'll get 4 writes and then 1, 4 writes on file 2, then 1, 4, until they're both getting pretty close to full, right? And if you add another one later on, again, round robin, but according to proportional fullness. And so back and forth it goes. First 1 small write, then 2, and then 20 on file 3. The better way to handle this is to create, and again, 4 is usually my starting place, and again, not just for TempDB, but also for every user database. Be sure to create them all the same size, and then also there's a trace flag you want to set that will cause them to all grow at the same amount. I believe that's trace flag 1117. And so what happens when you have all the same size, all the same auto grow behavior? SQL Server grows in a very predictable, very smooth, very balanced fashion across all of those drives. And so you get much better results that way. Everything fills up at the same rate. Everything has the same amount of I/O going to each of them, and you can actually do load balancing of your I/O if you have different drives perhaps, or different RAID arrays, or different LUNs on a SAN. So that's another little hidden performance tip. Another one that a lot of people don't realize is on the transaction log side, and this is called a VLF. Okay, and this is from a slide that Kimberly Tripp has written, and Kimberly actually taught me my first SQL Server class back in 1995, I believe. And so Kim is just the absolute expert on all things related to transaction logs and indexes and many other things. But what we have here is a situation in which our transaction log will auto-grow whenever it gets filled. And of course, we don't ever want it to not be able to do that. But what a lot of people don't realize is that every time you have to grow your transaction log, SQL Server will have to go in and create something called a virtual log file, a little VLF. And so, we continue to use this transaction log, and then it auto grows again, and it adds VLF number 3. Then it auto grows again, and it's VLF number 4. Now, I don't know if you've looked at the defaults, but again, this is the sort of thing in which the defaults are not really that helpful, because SQL Server, the default transaction log size is like 1 megabyte, and it's set to auto grow 10%. So that means the second time it grows, it's not the same number as the first time it grew. And the 15th time, it's not the same number as the 14th time. Each time it's 10% bigger than the total cumulative size of the file. And so you get really kind of erratic growths, it's not as predictable, but you also have to wait for this next auto grow to be initialized. And most damaging of all, unexpected of all, is on recovery. So again, I want to point you to the notes in which there's a blog post by Kimberly Tripp. And so she's actually kind of proven empirically that if you have more than 300 VLFs on a heavily used database, you're going to see performance begin to degrade. Okay, now that's your regular old standard OLTP performance is degrading. It's going down. On top of that, it is especially noticeable when you go to recover a database. And I had one friend who had a 1 terabyte, perhaps it was a 2 terabyte database, and they were not paying attention to this database. It actually had thousands and thousands of VLFs. I think it had 54,000. And if memory serves me right, and that added 2 hours to the recovery process for this database. 2 full hours. And I don't know about you, but I do not like it when the CIO is pacing around in my office asking me, when is it going to be ready? I don't want that to happen. It's fully within your control. So make sure that when SQL Server grows that transaction log, it does it in large chunks so that you only have maybe on a 2 terabyte database, you only have a couple dozen VLFs, and they're all 250 gigabytes in size, or 2.5 gigabytes in size. Just a large allocation so you don't have to have this happen a lot. All right, so I'm actually going to skip this slide because we're running short on time. But this is just some, some nice some nice recommendations here. You can come back and take a look at this. Another thing that is surprising to a lot of people is how important it is to have not just good indexes, but tight indexes. So there's this kind of argument you may have heard, designers and architects discussing, in which, well, are we going to have a natural composite key? Let's say the employee's surname, the employee's first name, and the ID for the employee, or are we just going to have an employee ID, right, and that we're going to auto-generate of our own? Well, if you have those 3 columns, it's going to be much bigger, take up a lot more space, but not just in that clustered index, because the clustered index is included in every non-clustered index. That's how it's able to, the non-clustered index is able to, utilize a pointer to find the specific record you need. And so, again, this can greatly, enormously increase the amount of I/O that has to happen for all of those non-clustered index reads that are happening around the clock. All right. Now, another couple quick notes, too, about database design. We see issues with inconsistent data types or oversized data types, that they never get utilized. I'm going to actually jump over to a demo now and show you a couple examples of this. I have a very detailed presentation called Secrets of the Optimizer Revealed Using Traceflag 8600, the series of trace flags. And it was done at the past conference, the past summit, and actually show you in there how just including a foreign key on a column that is already indexed, and it is a foreign key, you just haven't done a foreign key declaration on it, how adding that foreign key declaration can actually make the optimizer faster. So again, I don't have time to demonstrate all of those techniques to you, but let me, all of the red flags that is, but let me show you how to find some of these. All right, so let's take a look at a couple things. One thing that actually can cause a performance problem is if you have any stored procedures that are declared using SP underscore. And that's because it's actually a relic from its heritage as a Sybase product. And at that time, SP does not stand for stored procedure, it stands for system procedure, which means SQL Server will check in master to see if it exists. And so here in the AdventureWorks database, we do have two objects that begin with SP, but none of them are SP underscore. By the way, the reason I don't have SP underscore here in the where clause is because underscore is a reserve letter that actually is a wildcard itself, meaning any value for that one character. So that's not any good for us there. Now another one that is worth noting is this thing called an implicit conversion. Implicit conversions are kind of a ninja performance killer. They sneak in, they're assassins, and then they just destroy performance. What happens is there's a large number of data types that look like they are compatible, but in fact they are not. And what that causes SQL Server to do behind the scenes, here's an example. In AdventureWorks, if I've got the national ID number, SQL Server looks at that and says, okay, that is definitely an integer, and the column is an integer column. But what happens if I put quotes around it? SQL Server won't throw an error, but if it's quoted, SQL Server knows that this is actually not an integer value, it's a char or varchar value. And if we put the in front of it, then it's definitely an invarchar value. So when we execute those, they all work just fine. The problem is SQL Server will do a convert implicit behind the scenes. Let me actually rerun that and show you the execution plan on those. And whenever there is a convert implicit, it's just like if you can even see a little warning right there. That means the SQL Server has to do basically a cast or a convert function behind the scenes. And anytime you have a conversion function, or any kind of function for that matter, on an indexed column, SQL Server cannot use the column. So we should have been able to do a clustered index seek, but we can't. We have to do a full clustered index scan, which is really a waste of good performance, just letting it go to waste. So here's a query written by my buddy Jonathan Cahias. There's two versions in the script library that you can download. One is by Jonathan, and this is very precise, very specific. It works great. The only problem is, as you can see here, I only have 4 gigabytes of RAM on the SQL Server, and it is, it's still taking a few moments to run here. We're almost hitting, there we are, 10 seconds, and it's found these 3. Now, on the other hand, there's another one here from Panal Dave over at Authority. This looks at a different part. It doesn't actually scan the live cache here, and it comes back much faster, but what you're going to see is a lot of this isn't actually problematic. You have to look at the query text to find the first one in which we actually have a problem here. So this is showing us 10 times as many queries that actually don't have problematic convert implicit. There's another little useful utility here that looks for inconsistency. So these are, what it's doing is it's scanning the schema, and it's telling us if any of the data types are very different one from the other. Okay, so a lot of times that's not a big deal, because if they're close enough, for example, the start date column, yeah, they're all date. All right, not a big deal. We can live with that. We do have one here where the title value is different for this invarchar column. That's okay. A difference of invarchar 8 versus inchar 50, that will not produce a convert implicit. But if it was varchar, it absolutely would, because varchar is a standard encoding or standard storage, whereas invarchar is Unicode. So 1 is 2 bits per a digit in the sequence, whereas in varchar is 4. And so that means it's completely incompatible, even though they both have the word varchar or varchar, however you like to pronounce it. They're not compatible at all, and so you'll get that convert implicit warning there. I've got some other little nifty utilities in here. For example, I've got this hidden just for space savings, but there's a little script in here to tell you if you have any columns that are dramatically smaller in their usage than their declared size. And so it's possible you might come back and revise some of these so that they consume less space, particularly if they are used frequently in those concatenated indexes, multi-part clustered indexes in particular. Here's a nice little query written by a MVP from Italy, and Davide Mari. And what this does, and again, you'll have time to go back and look at these afterwards. But what this does is it tells us if we have any tables that are heaps that do not have clustered indexes. And also another thing that I'm looking for that might indicate a red flag would be if I have a ridiculously large number of non-clustered indexes. What that often means is I'm too heavily indexed. Maybe I even have redundant indexes. For that matter, there's also a query in here that shows you if you do have duplicate indexes on an individual column. There's checks in here to make sure all your tables have primary keys. Again, this is very important, and it turns out I have quite a few that do not. Checks for tables that have foreign keys, or foreign keys that don't have clustered indexes. Again, I mentioned that there are specific performance situations where the optimizer loses all kinds of options to improve performance if what is in reality a foreign key isn't declared inside of the database as a foreign key. So lots of good things in here for you to examine and spend a little time with. Okay. Now, when we look over here at red flags for database design, one that is quite interesting to a lot of people, they don't realize that this exists, is that there is a perfmon counter for any kind of deprecated events that might have executed on your SQL Server. So in this case, you can actually take a look and say, hey, I'd like to know about any deprecated events that have happened on this since the server was last started. And so you can see all of the different calls according to that version of SQL Server. So this does change over the different versions of SQL Server since they release different deprecated events and even undeprecate things over time. I think rather recently they actually undeprecated OLADB. I'm sorry, ODBC or something like that. So they had said they were going to get rid of one and favor the other, and now they've switched back and said, let's go ahead and make those usable again. Okay, so here's a query that lets us know if we have lots of objects in the cache that are single use only. They're only used one time. And so this can be an indication that I have a very high number of ad hoc plans. And so if I don't have optimized for ad hoc workload, I might need to enable that. And so in this case, look, I've got zillions of them. I've got almost 500, almost 600 in this case. There's some other checks for things like overutilization of cursors, of GUIDs. Now, this, again, was another one that was a surprise to me. GUIDs are typically okay for a primary key, but they're not good at all. In fact, they're bad for performance if you make them a clustered index. They cause an enormous amount of fragmentation and quite a bit of bloat due to page splits, which lead to empty or half-full pages. And so if you have GUIDs as clustered keys, you are definitely killing performance on a write-heavy application. In this case, nothing in master. I don't think we'll have anything in AdventureWorks either. Okay? So again, you might enjoy just taking a look through these different examples for database design decisions that could impact performance. And then finally, there's a whole collection here for you for instance and system level settings that are red flags as well. So in this particular query that I modified from Glenn Berry, this shows us a variety of settings and whether they are enabled or not. And you can see here in the code, I'm sorry, in the comments, what the preferred setting should be. For example, optimize for ad hoc workloads. Again, Glenn Berry's experience matches with mine. I always set that to 1, which means to enable it. Okay. Here are some of those trace flags that I mentioned that I like to know about if they're enabled or not. So you can check that, whether you have trace flags enabled with this particular command. And I don't have any enabled at the moment. Database level settings. And then one of the other things that I want to mention to you, if you are using a very old version of SQL Server, let's say you're using SQL Server 2008, do make sure that you are actually using Management Studio in the latest version. And one reason for that, I'll show you in just a moment, one reason for that is that, first of all, it's backwards compatible all the way to SQL Server 2005. So if you're using an older version of Management Studio, and you're missing out on some features. So in this case, you might know that a memory dump from SQL Server, not a good thing. Okay. So here's an example of a feature. I've got quite a few memory dumps here in my installation of Management Studio. There's a new add-on you can download for Management Studio, the latest releases of Management Studio. And so if you go to the Tools menu, you can have this new choice there called SQL Server Diagnostics. And what this enables you to do is upload to the Microsoft Azure Cloud any of your memory dumps, and tell it what region you might want to use, Australia for example, and you tell it what email address you want to get the report sent to. You can send it right, you can put it right here, and then you can upload either a zip of the memory dump. Of course, you know, they can be quite large, so if it's a couple gigabytes, you zip it up, or it can be the raw file. And it'll actually either email you or give you a report right here in Management Studio telling you if there are any known bugs or issues that you know came to bear in this particular memory dump, if there are any knowledge base articles associated with the origins of this memory dump, and if there are any fixes that are known related to the errors encountered in the memory dump. So you definitely want to make sure that you get the latest versions of Management Studio so you can take advantage of cool features like this. And again, backward compatible all the way into SQL Server 2005, and in a lot of circumstances, even to SQL 2000 if all you're going to do is query a database. So I hope that gives you a taste of some of the surprising performance issues that are kind of lurking inside of SQL Server if you just do everything by default. And with that, I want to go ahead and hand it over to Warwick if you'd like to open up with any questions. If we have time for that, I'm happy to stay as long as you might like.
Thanks, Kevin. We have got a couple of questions. So first off, can you explain quickly, or do you want the people to reach out to you, how to set the min and max memory, please?
So there's a couple ways to do it. The quickest rule of thumb is if it's just for SQL Server, and it's you know, you don't have any other major applications running on there, you don't have analysis services or integration services or anything like that, then simply enough you can take the total memory on that server. Let's say it's got 32 gigabytes of RAM, and you can get by with 2 gigs and just take away 2 gigs of that total memory and leave that for Windows. I typically like to be a little bit more cautious, and so I'll just right off the top take 4 gigabytes and give that to Windows. If there are other applications that are running, I actually usually like to take a little bit longer time, and I'm assuming that you probably already have a server up and running, And so there are a couple perfmon counters related to memory where you can say, I want to know how much memory each of these different Windows services, SQL Server being one of them, and how much memory they're consuming. And so you can see a little bit more effectively how much these other, let's say you've got analysis services on there, and it is only used, during the daytime hours and maybe an hour or two at night when you process a cube. So you might see that it spikes at times, but it never seems to use more than 8 gigabytes of RAM. So you could use the perfmon counters to get an idea of exactly what is the total allocation that other things need on that particular instance of SQL Server. But if you like, you can always send me an email, as I mentioned right here on the slide, kklein@century1.com, and I'll snip out the couple slides that actually go through painstaking detail and give you formulas and all kinds of things to calculate that.
Okay, following on from that, Kevin, if we've got a server that is running analysis services and SQL Server, what happens if the total amount of memory allocation exceeds the amount of memory that's available on the server?
Yes, this is actually a common problem. A lot of, in my opinion, it's just natural to assume that two Microsoft products made within the same business unit, the SQL Server, the data platform business unit, would know to check each other's behavior and adjust accordingly and effectively, when that is entirely an unreliable way to do things, as it turns out. So what you'll run into is you'll run into memory pressure issues. If it turns out you've got a server that has, again, just easy math numbers, but let's say it has 32 gigabytes of memory, and you go into SQL Server and tell it that it has 16 gigabytes of memory, and you go into analysis services and tell it that you have 16, it can have 16 gigabytes. Or let's say you go into each of them and tell them they can have 24 gigabytes of memory. And you have not told Windows that it can have any reserved memory of its own. What you'll basically have is a fight between each of these different set of processes for RAM. And so if you've over allocated, they will be stepping on each other's toes constantly and causing a lot of problems for each other. And so that's why you'll see so many kind of reference architectures in which the name of the game for high performance is to segregate the workloads out as much as you can, so that if you have an analysis services workload, it's on its own server, or at least its own virtual machine. SQL Server is on its own virtual machine, all within the same host. And the virtual machine memory settings and so forth are rigidly set. They're not allowed to balloon upward, or unpredictably. And so it's always a good idea to manually go in there and make sure that those numbers add up properly and do not exceed your total allocation of RAM.
Okay. So if we were running SQL Server on VMware, will it help to have multiple temp files and data files? And do we need to ask for local disk on VMware to take advantage of those multiple files?
So yes, the tempDB problems are caused internal to SQL Server. So whether that latch contention happens, first of all, you can check that by looking at the SQL Server wait statistics. And so you'll see a couple different wait statistics specifically related to latching issues. And so first of all, if you don't see latching issues very high on your wait statistics, then you really don't have to worry about it too much. It may be that your system is very powerful and and hasn't yet encountered latch contention on that SQL Server. So it's entirely possible that you don't have to do anything. But if you do see that latch contention is pretty high, then by creating additional TempDB data files, that can improve that performance problem, whether it's on a VM or a physical machine. So that's the answer to the first question. If latch condition is a bottleneck, then yes, it will help whether it's on a VM or not. The second question is a little bit more nuanced. So I have a VM. Should I use, and correct me if I've got this wrong, Warwick, should I use direct disk setups for those VMs? Is that right?
Do we need to ask for local disk on VMware to take advantage of the multiple files? So I'm not quite sure if it's the question's about direct attached versus VMDK.
Right, I'm not sure either. You don't have to have directly attached files, though, in order for the multiple files, TempDB files, to get that performance benefit. That's because it's an internal logical behavior of SQL Server, so it really doesn't matter what is behind it, whether it's VMDKs or, well, of course it's always VMDKs, but whether it's direct to disk or it's to a LUN or it's abstracted out in some way or another, it's internal to SQL Server.
Okay. What would you say the rule of thumb is to set the cost threshold for parallelism?
Yes, okay. Great question. And again, it is a bit more nuanced depending on the workloads and so forth. So one surprising thing that I've seen that some folks don't realize is that the default setting for max degrees of parallelism is 0, which means use as many CPUs as you might want to, SQL Server, when you decide that you need to parallelize. So if you've got 32 CPUs, I've talked to some people and they think, well, SQL Server might choose to use 16 or 24 or 32 CPUs. That's not actually what SQL Server does. What it does is it makes a determination and it says, if this particular transaction you're asking me to process will benefit from parallelism, I will use all CPUs available to me. Okay? So I shouldn't say often, my rule of thumb is to set, and it varies a little bit, again, according to the workload, but all things being equal, I always change the cost threshold for parallelism on a production system to at least 30, and maybe even higher than that. So what that means is the default for cost threshold for parallelism is SQL Server will check and say, I think this query may run greater than 5 seconds. The default is 5. And if I think it's going to run greater than 5 seconds, I need to parallelize it. I believe that's a little bit over-aggressive, and so, like I said, I usually set that to 30 and sometimes higher, sometimes 45, sometimes 60 seconds. I want it to be a really big query. Now, the next decision I have to make is, okay, SQL Server's decided to parallelize, but is this a server that has a lot of CPUs? If it is, I may not want it to use 32 or 64 out of 128 CPUs. I may not want that. So there are situations in which I actually do, I set both. So I always set cost threshold for parallelism, but under some situations when the server is highly parallelized and it can have very big workloads, that I want to make sure one particular query doesn't overwhelm all of those resources, I might come back in and say, let's set the max degrees of parallelism to 8. So now the SQL Server will never use more than 8 when it parallelizes anything, even though I have 64 CPUs on this SQL Server. Does that make sense?
Yes. Now, I guess this next one's an open-ended question, or it could be answered with one word. How do you diagnose SQL Server performance issues if the CPU usage is very high?
Well, you know what? That is actually a great segue because I'm doing a webinar tomorrow on how to do troubleshooting, how I typically approach troubleshooting. And it's sponsored by a pretty well-known company called Pragmatic Works, in case you're interested in that. Let me have, it's actually kind of late in the evening here, Warwick. Could you give me the question one more time?
How do we diagnose SQL Server performance issues if the CPU usage is very high?
Okay, so it's a multi-step process. And I'm curious what the one-word diagnostics you're thinking of when you said if you could do it in one word.
Sentry one.
Yes, thank you. Well, I've got that right here on the slide. Thank you so much. Yes, well, that's built into our product. So that it does indeed make that extremely easy to figure that out. Again, if I'm just going with the native tools, it's a multi-step process that's kind of arduous. You know, it's hard work. First, I always check to identify what the weight statistics are telling me, and if we have a lot of CPU consumption inside of SQL Server, then the next thing I do is look for the and again, if you need help with this, drop me an email and I'll share those queries with you and point you to a recording of the demonstration of these techniques. But I go from weight statistics then to looking at the plan cache to see who is consuming the most CPU. And then the bad news is you've got to do the hard work of potentially rewriting queries so that they consume as little CPU as possible, refactoring.
Okay, so the last question before we wrap it up for the month. Do you need to set optimize for ad hoc workloads in a data warehouse?
Great question. Yeah, very, very good question. So let me explain what the setting does, and you might decide for yourself. When you set the flag for, you set it to 1, meaning turn on optimize for ad hoc workloads. SQL Server alters its normal behavior for the way it retains plans in the plan cache. So normally what SQL Server does is it goes through the optimization process. It compiles and optimizes the code, the SQL code, and it puts the full execution plan into the cache when it is, when the query completes. And this includes things statistics and the histogram details of the query, and sometimes they can be very, very large if it's a complex query. So when you set the flag for optimize for ad hoc workload, what SQL Server does is the very first time a particular query or report or stored procedure is executed, SQL Server doesn't instantiate all of that code into the plan cache. The very first time it's executed, it puts in something called a query stub. I've heard it called by other names too, like a query thumbprint and a query tree. So it's abbreviated. It's not nearly as big as the full execution plan for whatever your transaction might be. And particularly in data warehousing applications, you tend to have very large, very complex, aggregating queries and things like that. So what that means is if the kinds of reports that are being run are just run with entirely different parameters each time they're invoked, or as the name of the setting implies, they're done entirely ad hoc, where everyone is putting in their own parameters for it, and there's no two versions of it that are very closely alike. Well, you wouldn't want 500 versions of this big reports execution plan, each one of them in the cache. You'd be giving up an enormous amount of space in the cache and having to do all kinds of buffering in and out of the cache and so forth. So by flipping on optimize for ad hoc workload, what it says is only on the second time it's run do I want you to put that full plan into the cache, because now I know that people are actually invoking this report or this set of analytics on the regular, right? So if you know the workload well enough and you know that most of those queries are only going to be used once before somebody else execute a different query that's really quite a bit different, you get a performance benefit when that's the profile, when no two queries are alike. If, on the other hand, it turns out that every manager is pulling the same report all across the company, then don't turn it on, because once that one plan is in the cache, you might like that to be fully instantiated in the cache and resident in the cache for constant and frequent reuse. So for a data warehouse, I would be more likely to disable that, right, to not enable it. But again, and I'm not sure if I still have the example up, but there are some queries you can look at that show you how often they are being reused. And so let me see here if I can find it. So look for query reuse here, and let's see, I think it's in the code example. And let me go up to the top here, and we'll see if we can find it. Yeah, so here's an example of execution plan reuse. So if you were to take a look at your data warehouse on your relational engine, if everything in there has a use count of 1, great. If, on the other hand, 90% of the things in there have high reuse counts, and only a portion of them have a reuse count of 1, so here we can see there are some that have very high reuse counts. Well, we wouldn't, those are getting reused heavily, so we wouldn't necessarily want a SQL Server to treat those as ad hoc queries. Did I muddle through that, or did that make any sense at all?
I think you did a fantastic job.
All right.
Well, with that brings us to the end of today's session. I'd like to say a big thank you to Kevin for giving his time and coming along and talking to us about the performance killers with SQL Server. I'd like to thank everybody for joining us for this session today. This is the last session for the year. Do ensure that you register for the session in January. We have got one of the presenters that Kevin has spoken about today in the form of Kimberly Tripp from SQL Skills. So ensure that you register, and I look forward to seeing you all in the new year. Thank you very much.
Cheers.